Hi everyone, this is class 3 part 2. So we'll solve the questions about continuity. Let's start. So here we have a function f of x, which is defined again piecewise, okay? So when x is not equal to minus 2, the function is defined by this, okay, 1 over x plus 2. And when x equals to minus 2, it's defined by this constant function 1, okay? So we sketch its graph, you know already that, okay? So you know 1 over x, so as we have here x plus 2, we shifted 2 units to the left, so we get this function. As the function is defined by 1, at this point at x equals to minus 2, we have this dot here, okay? It's defined as 1 at this point. So this is the graph of the function. So why this function is not continuous at this point, minus 2? Here we see that when we're approaching to minus 2 from left, we get minus infinity, right, as in here. And when we're approaching from the left, from the right, sorry, we get plus infinity. They are not equal. Actually, the limit does not exist. Okay, if a function is continuous, we say it's continuous at a point A if its limit when x is approaching A is equal to the definition of the function at that point, okay, f of a. So its limit does not exist, so it's not continuous, okay? So here we have another function at the second question, sorry. So here we have this function. Now we'll determine if we can remove the discontinuity, okay? So here we have this function. So what did I say before? We say it's continuous at this point A if we have this equality, okay? So let's check first if its limit exists. So when we're approaching 2, okay, we get this limit 6. How do we get it? So we write numerator in the parentheses of x, we get this. So we separate this, okay, we get x times x minus 2, x plus 1. So if we remove these ones, okay, we simplify them, we get this. When we put x equals to 2, we get 6 as limit, okay? So we see its limit exists, okay? So, but we see in the function, we cannot put x equals to 2, right? If we put, we get 0 here. So we need to define it at this point 2 as its limit with the same value as its limit, because we need to have this equality to remove its discontinuity, okay? So we know its limit 6, so we need to have this equality, okay? So it should be defined at this point 2 as 6. So we define a new function g, exactly the only difference between f and g is this point when x equals to 2, okay? This function gets 6 when x equals to 2. Otherwise, it's defined by f. It's defined exactly like f, okay? So we removed the discontinuity of this function f by defining this g, okay, at this point. So here we have a new problem, let's first remember intermediate value theorem here, okay? What does it say? First of all, we have this function, okay? First of all, we need to have a function which is defined on some interval, okay? B and A, okay? And we have here f of A, and here f of B. So this theorem says that if you have a function, let's call it f, if you have a function which is continuous at some closed interval, a, b, here we have this closed interval, okay, a, b, this interval, it is defined on this interval, which is closed, and it is obviously continuous, right? If you have this, okay, if you have this assumption, you have a function defined on this interval, which is continuous, okay? So here we have this. Then, for any number that you can pick from here, from this, okay, from this interval, what is that? It is between them, right? Here we have. So let's pick, let's here first, what does it say? So it says if you have a function which is continuous, okay, then for any number that you can pick from this interval between these two values, then there exists some number, let's call it C, okay, which is between now A and B, such that f of C equals to y, okay? It says this. If you have a function defined on some closed interval and continuous, then for any value that you can pick between f of A and f of B, then you can find some number C between this interval such that f of C equals to y. Here, let's see on the graph, okay? So here we have f of A and f of B, the interval. Let's pick some y here, okay? So what does it say? We need to find some C such that f of C is equal to y, and C should be in this interval, A, B. So here we see that C, we found C, and the function, obviously, it's defined on that C. Why do we have this? Because it's continuous, okay? That's why we can obtain such C, okay? So the theorem says that if you have some continuous function defined on closed interval, then for any y, you can find some C such that you have this equality, okay? It says this. Now let's see for what happens here. So here we have this function, okay? Actually, here we have this equality. We need to define first some function. It's so clear you have this function on this interval. Why we have this interval? Because the question says that, okay? So we need to take a closed interval. That's why we take this, okay? We will apply this theorem, okay, to have a root, okay, to find a root. What does that mean? If x0 is a root, then f of x0 should be equal to 0. We need to find some value x0, which makes this function equal to 0, equalized to 0. So here we have this function defined on closed interval. Now it's clear that f is continuous on this interval because sinus of x is continuous and the rest is polynomial. So we have a continuous function f, okay? Now, to find such x0, we need to find some value which makes f less than 0, okay? F of a, which is less than 0, and some f of b, which is greater than 0. If we can find some a and b, then we can say such x0 exists, okay? So we're looking for these a and b, okay? So we try just some values. F of 1 is, here we have sinus 1, okay? Just by definition of the function, we have sinus 1. And we know sinus 1 is greater than 0, okay? You should know this. So if you don't know, you can check the unit circle, okay? This is sinus 1, so sinus 1 is less than 0, is greater than 0. And what about 2? F of 2, we compute, just put in x equals to 2 and get this, sinus 2 minus 2. So what's the value of this function? It is less than 0 because, you know, sinus 2 is between minus 1 and 1, right? For any angle, it's between minus 1 and 1, okay? And if you subtract 2 here, you get something negative there, so it's negative. So we found 1, as in here, which makes f greater than 0, and 2, which makes f less than 0. So we can apply this theorem, intermediate value theorem, okay? We can choose 0 because it's between them, right? It's between these two values, f of a and f of b, okay? One of them is less than 0, one of them is greater than 0, so we can pick this value 0 such that, as I said before, it's between these two values of f. Then, by using this theorem, because it says that if you pick any number between them, you can find some number such that it gives you this equality. So as we have this assumption, then we know such a exists and it gives this equality. So what does that mean? As I said before, if we have this, then we say x0 is a root of f. So a is a root of this function f. As we desired, we found such number. Now here we have this question. We are looking for a number such that its cube is it's one more than its cube is exactly itself, the number that we took that we chose before. So we're looking such let's call it x, okay? Then it should satisfy this equality, okay? So one more, here we have plus, then its cube, here we have x cube. So as itself, okay? So it is exactly one more than its cube. So we're looking for these x. So here we have this equality actually, right? We can write this x on the left. So here we have this equality. Now this equality actually is the left side of the equality is a polynomial, right? So it's continuous everywhere, okay? Let's try for some values here. When we see, when we put x equals to 1, we get 1. When we put x equals to 2, we get 7. And when we put x equals to minus 2, we get minus 5. So to find such number, we need to have this equality, right? If we can find some x which satisfies this, then we will find that number, okay? So we need to take this 0 if we have some interval. That's why we need to take this minus 1 and 1, which means this interval, 1, minus 2, okay? On this interval, if we call this f, on this interval, we see f of minus 2 is minus 5, and f of 1 is 1. So we can pick 0 between them, okay? So here we have this interval and we pick 0, and intermediate value theorem says that as 0 is between them, minus 5 and 1, the values of f, intermediate value theorem says that you can find some x0 between this interval, okay, such that it gives you this equality. That 0 is this 0 that we pick here. Hope you understand. So see you next week.